before the test and any quizzes we have, I will give you a formula sheet, but you are responsible for making your own to use in class and homework and that kind of stuff, okay? Yep, we're doing 9.4. Okay, now I need my notes. Looks like we are on page 9.4, or page, back of page 61. Back of page 61. All right, so who am I missing today? Everybody back there. Kendall and Simone. I had to, they're short on chairs. So some of our chairs are missing. Be sure to have everybody. No Sunny.
Isaiah's not here.
Aaliyah's not here.
Alrighty, so here we go. I'm going to put a couple of sequences of numbers up here, so just lists of numbers. And I want you to tell me if you can tell the difference. So there's one set of numbers. And there's another set of numbers. Now, would you agree that both sets are predictable? In other words, you can tell me what comes next? Yeah, in both of them. But how we're getting those numbers is different. What's happening in the first one? We're adding 2. When you get from term to term by adding the same number, that is called an arithmetic sequence. An arithmetic sequence. So what is an arithmetic sequence? You get from term to term by adding the same number. We get from term to term by adding the same number. What usually happens when I have you put definitions in your notes? They eventually show up somewhere, right? So what's an arithmetic sequence? You get from term to term by adding the same number. Okay? Now, that number can be negative. So in other words, the terms don't have to be getting bigger, they could also be getting smaller. But the difference is the same. Okay. The number that you add the number you add is the common difference. Now in a minute, I'm going to put a formula up here that's going to have a D in it. And the D is the common difference. So for this problem right here, D is 2. The number I am adding is 2. I'm always going to be adding the same number. So there's one D. In this case, it's 2. Now, what about this guy right here? What's happening here? We're multiplying by 2. When you get from term to term by multiplying by the same number, you're a geometric sequence. So you get from term to term by multiplying by the same number. Obviously, if we multiply by a number like 1/2, our terms will get smaller. They don't have to be getting bigger. They can be getting smaller. The number that you multiply by is called the common ratio. And in our formula, you'll see the letter R. That stands for ratio. Now, I don't have any formulas up there yet, but when I do, one of them is going to have an R in it. Okay? All right, before we get to the formulas, let's see if you can do problem number 1. Identify the following as arithmetic, geometric, or neither. All right, so let's look at number 1. What do you think about A, letter A? Geometric. What is the ratio? If it's geometric, you're getting from number to number by multiplying by R. What is the R in letter A? 1/2. Aren't we multiplying by 1/2? Would someone nod or something? Yeah, yeah, we're multiplying by 1/2. Good. Okay, what about B? Arithmetic, and we are, when it's a noun, it's arithmetic, when it's an adjective, it's arithmetic. I don't know why that is, but anyhow, arithmetic. What are we adding? What's our D? 10. D is 10. So write for letter B, arithmetic, D equals 10. If you're arithmetic, you have a D. In this case, it's 10. All right, what about C? Arithmetic again. What am I adding? 8. D is 8. How about letter D? Can you see what's happening?
Yeah.
What's happening? We start out by adding 2, then we add 4, then we add 6. Well, wait a second. Is that arithmetic? No, because if it's arithmetic, we have to add the same number. So D is neither arithmetic nor geometric. Now, you figured out the pattern. You can still have a pattern. You can still, continue the sequence, but it is not arithmetic or geometric. Does everyone understand that? It's not adding that makes it arithmetic. It's adding the same number. Okay? Got it? All right. What about E? Geometric, the ratio is 2. 2. We're doubling. Times 2, times 2, times 2. F, I think, is the one I have on the board. F is arithmetic with a common difference of plus 2. 2. And what about G? If it's arithmetic, I have to add the same number. Am I adding the same number to get from term to term? No. Okay, that's a neither. Does anybody know what those numbers are? Those are very special numbers. What are those numbers? 1, 4, 9, 16, 25. Those are the squares. 1 squared, 2 squared, 3 squared. So again, there's a pattern, but it's not arithmetic or geometric. Okay, now number 2. We have to start getting used to sequence notation. So let's see. And your job is to find B sub 1, B sub 2, B sub 3, B sub 4, and B sub 7. Okay, so that's how we say that. B sub 1. B sub 1. And what that means is the first term. Remember, we're talking about a sequence of numbers, a list of numbers. This represents the first term in the list. This represents the second term in the list. Guess what this is? And that would be the 70th term in the list. Okay? Now, it's super simple. We're not making this hard. It is so easy. The formula says B sub n is 6 over n. So what do you think B sub 1 is? 6 over 1. Exactly. It's that easy. You have a formula. You are going to plug in whatever they put right here. So what's B sub 2? That would be 3. B sub 3 would be B sub 4 and B sub 70. I reduce my fraction, 6 over 35. Now, I've got them written vertically, but the sequence would look like this. 6, 3, 2, 3 halves, dot, 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 3 35ths. That's your list of numbers. Is that guy arithmetic or geometric?
Geometric.
Now, if it's geometric, it means I'm multiplying by the same number. So what am I multiplying by if it's geometric? I don't think it's geometric. I don't think it's arithmetic. I think it's a cool little sequence, but it's not anything special. That seemed almost too easy to be true. Let's look at the next one. All right, I want the same thing. So C sub 1, 2, 3, 4, and 7. So we're not making it hard. How do we find C sub 1? This is C sub n. So C sub 1 will be
3.
2 times 1 plus 1, which is 3. Yep. And C sub 2 will be 2 times 2 plus 1, which is 5. You're getting it. What's C sub 3? 2 times 3 plus 1, which is 7. What's that guy? C sub 70. 2 times 70 plus 1, what is it, 141?
Yeah.
Now, remember there's a big gap in here. Look at these first 4. Arithmetic or geometric?
Arithmetic.
Definitely arithmetic with a common difference of 2. see that? Because now we're gonna have to write our own formulas, okay? So you see how they work. All right, so now we're ready for number 3. Got some crazy vocabulary here. So I have an arithmetic sequence. Now, the directions told me that was arithmetic, but could you have figured that out? You can figure that out, right? You can tell that's arithmetic. Okay. What are we doing? We're gonna find the common difference. Right, you can do that. What am I adding? What? -4. I'm adding -4. Would everyone agree with that? Now I gotta find the 8th term and the explicit rule for the nth term. This is what we call an explicit rule. So the formula is the explicit rule. Okay? But first we have to find the 8th term. This means the 8th term. Remember, this meant the first term. Plug in 1. This meant the second term. I need to find the 8th term. Well, how many do I have up here on the board? 4. Could I keep my list going? The next one would be -13, and then -17, -21. I think that's the one I want, right? 1, 2, 3, 4, 5, 6, 7, 8. So right there. Now notice, boys and girls, just like in the last test, you're gonna have a calculator the whole time, okay? So could you just take -9 was our last number and do -4, -4, -4, -4? Could you do that? Absolutely. And that's fine if all you're looking for is the 8th term. But what if we wanted the 800th term? I don't think you'd want to do it that way, right? That's what we use a formula for. So remember, for your own use, you are building your own formula sheet. So I don't know where you're going to start writing these, but figure out a place where you're going to write them so that you can find them when we talk about them in class. All right, so for an arithmetic sequence, your formula, for an arithmetic sequence, your formula is this. You do not need to memorize that. You'll always have the formula, but you need to know what all those things stand for. We already know what D stands for. What does D stand for? The common difference. And in our problem, the common difference is what? We figured it out. What's the common difference? The common difference is the number that you keep adding. So the common difference is -4. What does this stand for right here, A sub 1? The first term, which is 3. This stands for the first term. A sub 1, term 1. When I write my formula then for this, oh wait, that was -25. When I write my formula, A sub n, that's my explicit formula, A sub n equals the first term, which is 3, plus the common difference times n minus 1. I'm plugging in this number and this number, both of which I know from my sequence. Remember, I'm building a formula. I'm not getting an answer, I'm building a formula, so it's okay to have letters. So let's simplify this. What's it say? 3 minus 4n plus 4 if I distribute. So negative 4n plus 7. Remember from the last problem, I erased it, but I told you this is from the last problem. I said this is what an explicit formula looks like. Is that what ours looks like? Yeah. Now, just for fun, remember when we found a sub 8 and we did it by counting down? What if I used my formula? What would a sub 8 be if I used my formula? A sub 8 would be negative 4 times 8 plus 7. Plug in 8, a sub 8, plug in 8. What's that? What is that?
25.
Negative 25. Isn't that what we counted down to get? But now that you have a formula, if somebody says find the 800th term, you aren't worried. You aren't worried. You're not going to count all the way down 800 of those numbers. You're going to put 800 right here. So what would the 800th term be? Negative 4 times 800 plus 7. What is that? We got Kleenex back there right here. Negative 3,193. So, while you can always count in your formula, or in your sequence, having a formula makes it a lot quicker, especially if it's a big number. All right, I'm gonna erase this. Anybody have a question about it? I'm gonna start the next one. Okay, we're gonna do exactly the same thing. Look at your sequence and figure out what your D is. What's our D?
Minus 0.5.
Negative 0.5. That's my D. Agreed?
Yes, ma'am.
Now, I want the 8th term.
6.5.
So unless I build a formula, the only way I can have to get the 8th term is just to keep going. So after this would be 8, 7.5, 7, 6.5, I think that's the one right there. So the 8th term is 6.5. Now I need to build my formula. Every arithmetic sequence, if it's arithmetic, here's your guy, right here. So what's a sub n gonna equal? 10
Negative 0.5.
plus negative 0.5 times n minus 1. All you do is plug in your first term and your difference and clean it up. So 10 minus 0.5 then plus 0.5. Distribute right here. So So negative 0.5n plus 10.5. Does that look okay? Now let's check this. I think we're right. I mean, we wrote it out. We gotta be right. But let's see if our formula works. According to our formula, right here, a sub 8 should be negative 0.5 times 8 plus 10.5. Okay, would somebody type that in on the calculator? What do you get if you take negative 0.5 times 8 and add 10.5? 6.5, which is exactly what it should be, right?
Yeah, boy.
All right, one more. Just exactly the same kind of problem. Take a minute on your own and see if you can find the difference in the eighth term and the nth term
It's too funny.
for this sequence.
Okay.
Cam, I don't know what you're doing. I need your focus. The last 2 days, I've had 2 seniors cheat. And one senior lied to me right to my face. I'm not having a good week. So don't push me over the edge. I can handle dumb kid stuff. I can't handle cheating and lying. Cheating and lying, no. Makes me mad. Okay, we're finding the common difference. You should have that pretty quickly. You should be able to look at this and tell. What do you think your common difference is? 6. Perfect. Now, if you do this one first, you can just count out. Anybody got that? Anybody go out? What did you get out there? 52. Okay. Seems reasonable.
6m plus 4.
And then this will be 10 plus 6 times n minus 1. 6m plus 4, is that what you said, Maria?
Yeah.
I think you're right. And then just for jollies, I'm gonna go ahead and check this answer. I'm gonna put 8 in right here, a sub 8. So that would be 48 plus 4, 52. Now remember, we're building a formula so that we can find the 100th term without doing this, right? We don't wanna do this out to 100. 8's okay, but the formula is gonna help me find any term I want. All right, let's turn the page. Whoa. This looks harder. All right, let's look at number 4. Alright, the following terms of an arithmetic sequence are given, okay? Find the first term and the 100th term. Okay, so let's draw a picture of this. Here's the first term, second term, third term. Here's the, remember, a sub 4 means 4 what that means. The sub is the term number. So there's the fourth, fifth, sixth, and the seventh term is 22. What kind of sequence is this? Arithmetic? And what does arithmetic mean? Add the same number. So let's kind of forget about all this. If I am at 13, don't I add a D to get to here? And then I'll add another D to get to here. And I'll add another D to get to here. So would you agree I am going to add 3 Ds? I'm adding 3 Ds.
And the number.
So 13 plus 3 Ds should give me 22? So if I subtract 13, it looks like 3D is 9. So I am adding 3. D is 3. So this would be 16, this would be 19, and that's 22. Now what if I go backwards? Well, I will be, this way I'm adding 3. This way I will be, so this will be 10, 7, 4. One of the questions said, what's the first term? The first term is 4. Okay? Now remember your formula. To write the formula, you need to know the first term, which we do, is 4, and you need to know the common difference, we do, it's 3. So our formula for this sequence, excuse me, is 4 plus 3 times n minus 1. 4 plus 3 times n minus 1. So cleaning that up, like we've been doing. 3n plus 1. Would you agree with that? So now the question says, find the 100th term. That's easy. Once I have my formula, that's easy. What's the 100th term? A sub 100.
301.
301. Absolutely. And that wasn't so bad. It looks scary. All right, let's look at B. A sub 3 is 8, and A sub 7 is 36. Now, all this sequence stuff is just logic. So some of you are just logicking it out differently than me, and I'm totally so okay with that. But what I like to do with this is I like to draw the sequence. So there's the first term and the second term. Now, the third term is 8. This is the third term. There's the fourth, fifth, sixth, seventh. I didn't plan very well. Let me do it down here. So here's my third term. Here's my seventh term. Now I know that to get from here to here, I have to add a D, add a D, add a D, add a D. So this time I have to add 4 Ds. 1, 2, 3, 4. And adding 4 Ds is gonna get me from 8 to 36. So 8 plus 4 Ds is gonna get me to 36. 8 plus D, plus D, plus D, plus D, puts me at 36. So 4D equals 28. I got D equals 7. And I can check that, because if I add 7, I get 15, another 7, another 7, and another 7. It's all good, but now I need to go backwards. Because if I'm gonna write my formula, oops, I can't erase that. If I'm gonna write my formula, I need my first term. So let's go backwards. What would this guy be? 1, and this will be -6. So now I can write my formula, a sub n equals -6 plus, what was my difference? 7 times n minus 1. How does that look to you? Good? So now I want the 100th term. So I just plug in 100. And the 100th term is, I don't know, 700 minus 13, what is that? 687. Alright. There's one more. Try that one on your own. And I'd love to have a volunteer come up and do it on the board if you're comfortable doing that. I'll write it down. You gonna do it? Okay, so you're gonna- actually, when you were counting back to your first term, you were adding 3, right? What's 8 plus 3? Yeah, and then that'll change that 15 also. Okay, Max got his D to be 3. Actually, -3. Did you get -3 for your D? Good. And then he counted back, but since D was -3, when he went that way, he actually had to add 3, because he was going the other direction. So he went all the way back and he got his first term to be 14. Did you agree with that? And then he got his formula by plugging in 14 for A sub 1 and -3 for D. And now he's plugging 100 into his formula. And that's what I got, -283. All right, that's enough for today. We will do today we've done mostly arithmetic, so tomorrow we'll focus on numeracy, we'll focus on geometry. Thank you, Max, appreciate that. I won't assign the homework, but if you wanna look at it, you can probably do the arithmetic parts of it.